Well, dear students, I welcome you again to the fresh lesson, that is again lenses. Now, we have studied about lenses. There you have studied about the formation of images in concave and convex lenses. Now, we are to just think of the uses of concave lens and convex lens. When I just talk of concave lens, concave lens is not used in many of the cases. Its use is limited. But use of a concave lens is very important. A convex lens is used in particularly optical instruments. In optical instruments, convex lens is used. What are optical instruments? Now here you see that one. Photographic camera is an optical instrument. Telescope is an optical instrument. Binocular is an instrument, optical instrument, and then uh, even reading lens is an optical instrument, and similarly compound microscope is an instrument, optical instrument. Here we make use of convex lens. So convex lens has got many uses in optical instruments, but concave lens cannot be used because it always produces what it always produces, not a which one enlarged image. It always produces a diminished image, and that's one of the important characteristics. And hence, we don't make use of a concave lens. We make use of a convex lens here. Convex lens has got many uses. As I told you, it is used in optical instruments like photographic camera, telescope, even in binoculars it is used there, and in reading lens it is used, in compound microscope that is being used. They are the important uses of what you call, which one? A convex lens. And then coming to the other aspect of the thing there, that is uh, today we are taking another aspect, that is what do you mean by power of a lens? The very important aspect about which we have to just think of. What do you mean by power of a lens? Power of a lens. Power of a lens is defined as, power of a lens is defined as the reciprocal of the focal length of a lens. The reciprocal of the focal length of a lens is called what you call power of a lens. Therefore, it is like this: P equals 1 upon F. It is the reciprocal of the focal length. Power of a lens is defined as the reciprocal of the focal length of the lens. And power of a lens is expressed in terms of diopters, diopters, in terms of diopters. Power of a lens is expressed in terms of diopters. Now comes the question, what do you mean by 1 diopter? If the focal length of a lens is 1 meter, please understand, if the focal length of a lens is 1 meter, then the power of the lens is said to be 1 diopter. If the power of the lens is 1 diopter, then the focal length should be 1 meter. If the focal length of lens is 1 meter, then the power of lens is said to be 1 diopter. I hope you just understand. And the power of a convex lens is considered to be always positive. Power of a convex lens is always considered to be positive, Power of a concave lens is said to be always negative. Suppose I say the focal length, let us say, focal length of a convex lens is 25 centimeters. It is 25 centimeters. I have converted into meters. What is 25 centimeter? What is it equal to? 25 by 100. That is equal to 1 by 4 meter, right? Am I right? 1 by 4 meter. 25 centimeter means 25 by 100. That is 1 by 4. That is equal to, let us say, 0.25 meter, right? If the focal length of a lens is 0.25 meter, then what is the power? P is equal to what? 1 upon, let us say, 0.25 meters. That is 100 ಆಯಿತು by 25 ಆಯಿತು. That means 25 by 100 400 ಎಷ್ಟಾಯಿತು? ಅಲ್ಲಿ 4 ಆಗೋಯ್ತು. ಹೌದಾ? 0.25 ಅಂದರೆ 0.1 ಹಾಕಿ 2 0 ಹಾಕಿ divide by 25. That means, please understand, that is, it is plus 4 ಅಂತ ಹೇಳ್ತೀನಿ. It may be minus 4 ಇರ್ಬೋದು, plus 2.5 ಇರ್ಬೋದು, minus 2.5 ಇರ್ಬೋದು. I hope you understood this one. So anyhow, you please understand this one. Power of a convex lens is always positive. Power of a concave lens is always negative. ಅದನ್ನು ಮುಂದೆ ಲೆಕ್ಕ ಮಾಡಬೇಕಾದ್ರೆ we should just try to understand. Today we must understand how to express the power of a lens. And what do you mean by power of a lens? Power of a lens means what? Power of a lens. Power of a lens is expressed in terms of which one? Diopters. That is the SI unit. Power of a lens is 1 diopter if the focal length of the lens is 1 meter. I hope you just understand. That's the thing there. And the last point I have just discussed here today is, what are the conditions? What are the conditions under which no refraction of light takes place? It's a very important point. What are the conditions under which no refraction of light takes place? ನೋಡಿ ಹೇಗಿದೆ. ರಿಫ್ರಾಕ್ಷನ್ ಆಫ್ ಲೈಟ್ ಆಗಲೇಬಾರ್ದು ಅಂತ ಹೇಳಿದ್ರೆ ಏನು ಕಂಡೀಷನ್ನು? ನಂಬರ್ 1, the ray of light should incident on the surface at right angles. If a ray of light incidents normally means at 90 degrees. If a ray of light strikes a surface normally, or if a ray of light incidents at an angle of 90 degrees, no refraction of light takes place. The ray just gets out in the same path. Second condition is the refractive index should remain the same. If the refractive index of the second medium is also the same, no refraction of light takes place. Please understand. If the refractive index of the second medium, if the refractive index remains the same, of the medium remains the same, it does not change. If light travels from air medium to air medium, no refraction takes place. If the ray of light travels from glass to glass, no refraction takes place, because mu remains the same. The value of mu remains the same. So there are two conditions on which no refraction of light takes place. I think you have understood all these points, and we'll have to just do the the problems. Before I work out the problems, you must understand certain things. What is the mirror formula? I think I have told you. What is that mirror formula? Mirror formula is 1 over u plus 1 over v equals 1 over f. I think I have discussed this one. So, the mirror formula is 1 over u plus 1 over v is equal to 1 over f. What do u, v, f mean? U represents the object distance. V represents the image distance. F represents focal length. So, 1 over u plus 1 over v is equal to 1 over f. That is called mirror formula. Similarly, there is lens formula. Lens formula is altogether different. 1 over v minus 1 over u equals 1 over f. ಇನ್ನು ಪ್ರೂಫ್ ಇಲ್ಲ ನಿಮಗೆ. ಸೊ 1 over v minus 1 over u equals 1 over f. That is what you call, which one? This is called the length formula. 1 over v minus 1 over u is equal to 1 over f. This is the length formula. And we have to work out the problems with respect to mirrors and lenses. And we will take up that one tomorrow. Tomorrow I'll just take up which one? The various problems on the mirror and lenses. ಎರಡು ತೊಗೊಂಡ್ಬಿಡ್ತೀನಿ. ನೋಡೋಣ, we shall try to work out. ಮಿರರ್ ಫಾರ್ಮುಲಾ ಮೇಲೆ ಒಂದು ದಿವಸ ಮಾಡಿ, ಲೆನ್ಸ್ ಲೆಕ್ಕನೇ ಬೇರೆಗೆ ಮಾಡೋಣ. Okay, thank you. Bye. A small lesson today. May God bless all of you. Good evening.